Hello everyone, thank you for tuning in with Recro and welcome to our another session. So we are starting a series for backend now, and for this week we have decided to go ahead with Kubernetes. And this is Sana. I'm a community initiative lead at Recro, which is a developer focused organization wherein we are trying to connect with high growth startups, wherein we're working with all the high growth startups like YourFit, Dunzo, Swiggy, Bounce, wherein we are trying to connect developers' aspiration to the right opportunity. So, yeah, so that's how it is. And we are having today Ankur Jain. So, Ankur is a software engineer in Partsavatar, which is a Canadian e-commerce company, and he will be telling us more about Kubernetes. I think it was a very hot topic, and I got a lot of people saying that to do the session on this topic. So yeah, today we are doing that. So Ankur is working with Partsavatar. It is a Canadian startup, Canadian e-commerce company, and yeah, I think he will be the best person to tell you more about the topic which we are going to discuss. And here, I'll be telling you about the platform which we are using right now. So this is AirMeet, and on the right hand side, you can see four options. Yeah, four. One is sessions. So in this session, we will be having around three sections. So one is welcome session, which is going on right now, and then the second one would be the demo and Q&A. So we are going to have three demos today, in which every demo will be followed by a question answer session. Okay, so that would be for that particular demo which we will be doing. After that, we will be having a dedicated Q&A for the whole session. And down that, you can see attendees. That is like people who are attending the session with you. So over to you, Ankur.
Yeah, thank you, Sana. All right, guys. So let me introduce myself. I'm Ankur Jain. I'm working as a software engineer at Partsavatar, Canada. Before that, I was working with Petronas Malaysia. I've been working with Shuttle as I worked with Shuttle before, yes, and I've been working mostly on backend technologies and server-side architecture. That's what my domain has been. So I welcome you all to Kubernetes 101. Today we'll try to cover what is Kubernetes, why it is important, and we will try to deploy one of the Flask app to the Kubernetes cluster. All right, and then we'll try to access it outside the cluster so that we can have a functioning Flask app deployed. Okay. So without taking much of your time, all right, let me start it. Let me share my screen. All right. Can you guys see? I think you guys can you guys see. I don't know. Okay, great. Awesome. Okay, so welcome to Kubernetes 101. Let's get it started. We will start with uh, with a very basic definition of what is Kubernetes. Okay, so Kubernetes is a production grade container orchestration system. All right. Now, if you look closely, there are only two important words here: container orchestration. Okay, so in simple terms, Kubernetes is there to orchestrate your containers. Okay, now before I even start into Kubernetes, we need to have a basic understanding of what are containers, right? Because at the end of the day, Kubernetes is there for the containers in general sense. All right, so let's start with what is a container. Okay, and this is what an official definition from Google looks like, that a container is a standard unit of software that packages up code and all its dependencies so that application runs reliably from one computing environment to the another. All right, uh, too many things to process here. uh, in simpler terms, a container is an isolated process that is running on your operating system. Okay, it's just a process that runs on your operating system. A container has its own process namespace. So what I mean by a process namespace is that any process that runs inside a container is unique to that container only. And these process inside a container cannot interact with anything outside the container unless and until you explicitly connect them, which we will see in a moment. Now, a container is really important because it has all its dependencies, your application code, OS level binaries, everything is wrapped inside a package. And then container has everything with it in that package. And it's just running that package. All right. Now, what is that package? Because that's what make container unique, because everything is inside a package. All right. So that package is called the container image. In simpler terms, a container image is a binary representation of your application code, dependencies, libraries, operating systems, and everything into a single file. Okay. So when you package all this thing into a single file, we call that single file a container image. And container is the runtime, or you can say runtime instance of that container image. Okay. So if you look here, there are like app 1, app 2, app 3, which have like binaries and libraries, everything. These three apps, if they are different, they will each have their own container image. And these all container image will have a 3 container instance. And those 3 container instance are basically running on your operating system. Of course, there's an infrastructure below it. Infrastructure, you can assume it's like your RAM, CPU, and all those resources. Now, the question arises that who is creating these containers from that file, the container image that we talk about, right? There has to be some system that is creating these containers from that file, right? The container image. That is done with the help of a container runtime system. Container runtime is responsible for managing the containers, their containers lifecycle, image building, image lifecycle, and basically just creating the containers from the container images. All right. um, we'll see how this thing works in a moment. Now, before I go to the demo, a very important question that should come to is why this container technology becomes famous. All right. What was it that people thought that, hey, we need containers, so we need a technology that is similar to the containers. All right. There are two major reasons for it. The first one is called the dependency matrix hell. So this is what a usual traditional deployment used to look like. And this is what I used to do like few years back when I was deploying even my personal softwares or my personal code onto the any infrastructure. You have a big fat VM with like 16 gigabytes of RAM. You put everything into one big fat VM, Angular, Redis, MySQL, Node, Python. And now what happens is all your things are basically into a dependency hell. So if let's say I want to update one of the operating system dependency to maybe version from A to B, it might break MySQL or an Angular dependency that will make that basically the application won't run on it, right? So now you're updating a dependency from A to B, you might have to update all the other dependencies which are dependent on that particular dependency. And that creates a really complicated to update a system or even to basically patch a security into the operating system, or even just like a normal dependency. Maybe you're updating an npm package and it might break some dependency in it, right, of the operating system level, which might break the dependency for a Redis. It might happen. So how container solves it, right? Like I say, the containers have everything packaged inside a container image. So when you start a container has everything with it. And when you remove a container, then everything is gone. Your operating system is clean. It's never polluted. Basically, it doesn't even depend upon the operating system much. What is more dependent on the container runtime? Its operating system is irrelevant for the containers. All right. So that keeps an operating system clean. That is a very good advantage of containers. The secondary thing is easily build, test, and deploy. And this is what I've heard a lot of time, that this thing is working on my machine. I have no idea why it's not working on edtech or maybe a dev server. And this is true. And I can give you a real life example for it. So a few years back, I was working on Python and I was using a library called PyCrypto for hashing it. And I was using Ubuntu at that time. And I installed PyCrypto with just a normal pip install PyCrypto. Everything was working fine on my local machine. Then we moved the code to the dev server and it broke. And I have like no idea why it was breaking. So we find out that dev was using the CentOS version of I don't know which version it was. Maybe it was 7, I suppose. It was using a CentOS, but that's fine. The problem was that PyCrypto needed a library, a GCC library, to be present on your operating system, and it was not present on Cent. It comes by default with Ubuntu, but it doesn't come by default on the CentOS. So we were like, okay, great. Like, what's the harm? We just do a yum install on the CentOS, and we will get that library. Like, how hard it could be. We did a yum install on the CentOS server, on the dev server, and we realized, great, that library is not present in the package manager. And then we realized, wow. And we tried to find an alternative to PyCrypto, but we couldn't find at that time for the thing which we were looking for. So we dig more deeper into it, and then we realize that we have to actually build it from the source. So we get the code from the GitHub. We literally build that GCC library from the source, and then we did a pip install, and then it finally got installed on the dev machine, and it worked fine. But then we realized that we have to replicate it to the integ and the prod server, and that is not a very good way of deployment, because you have to replicate it, and think about the ways when you have to replicate it across maybe a fleet of servers. That is not a very good way of deploying things if you have to actually building it something from the sources, right? So with containers, I can assure you that 99% of the time, if the container is working on your local, it will work on any operating system that supports that container runtime. All right. So you just code everything on your local, you run the container works fine, just push it onto dev or whatever server you want, it will work because it is independent of the operating system. It has all the libraries packaged inside the container. So if you're building a container with a CentOS as your base image or your operating system, and you're installing PyCrypto on it, you will find that thing on your local. It will not get installed. And then you can do whatever you want. You can then compile the GCC from the scratch and then add the dependencies on it, on that container, and then package it. Once it's packaged on your local and pushed to the whatever repository you're using, it will run beautifully irrespective of the OS that I'm running on the servers. That is very good thing with the containers. All right. So now we should now basically let's look at demo. So I like Docker as a container technology. It's my personal preference. It's not the only one available. A lot of people I've meet, they just come and say ki they just associate Docker with containers. Like Docker is the only container technology available outside. No, it's not. It is one of the container technology available. There is Linux containers. Rocket is a technology which is getting very famous with the apart from the Docker. But I think we will stick with Docker for the time being. Okay. Let's actually see this, right? Let's see what this thing is, because talk is not very good for infrastructure kind of things. You should actually try these things. Okay. This is my terminal. Is it on full screen? Yeah, it's full screen. Great. So, okay, I have a, I don't normally work on this. So I have a Ubuntu server here. Okay. This is my Ubuntu server. Great. I have a Docker installed. Yes, you can actually install it. It's not that difficult to install. I think it's a sudo apt install docker ce. I didn't do it. I can do it right now, but it's not worth it. It's a very single line install, and it takes some time. I think it's a decently sized package for a Docker, so I just have it installed here. Okay, great. Let's go to a Flask. Okay, so this is my Flask app. Okay, it has what? It has what is this? It is just a requirement.txt of Flask app, and then I think it has one single file. Yeah, it has a one single file. It is running on port 8000, and when you hit root, it just gives you a hello world. Let's try to run it. I think I might have. Yeah, I have an environment activated. Yeah, let's run this. Python run.py. Yeah, I'm running it, and if I go to my server again, I should be able to access this on localhost http 7.0.0.1 8000. Yeah, I can access it. Okay, it gets a hello world printed. Now I want to package this in a container, so I need to build a container image for it. Correct. Let's build a container image. So with Docker image, basically you need a Docker file. Now, the trend is to name it Docker file and put it into the same directory as your rest of the code. You can name it whatever you want, but then you have to point it to the direction. Then you have to point the Docker to the direction of where the file is present, of course, with the name of it. The general trend is to just name it a Docker file, put it into the same directory where all your code is located. Let's just do this. Okay. Now, how to build a Docker image? This is really interesting. Docker images or any container images in general trend are built on layers and layers and layers over it, right? It's like a tree-like structure. You had a root image, and then you just keep on adding multiple layers to it. Okay. So we will start with a base image that is depicted by the from keyword. Okay. Now, what kind of base image do I need? People prefer Ubuntu and whatever you want. I prefer Alpine. Alpine is a Linux, and I need a version 3.7. Sorry, I need a version 3.7 of that Linux. Okay, so this is my base image. Now, with this base image, I will try to add more things over it on layers and layers and layers over it. And the best thing about Docker images is, so let's say I'm using an Alpine 3.7 on this machine, and I built another image with the same base image of Alpine 3.7, then Docker will use that same image from the cache. It will not try to fetch it again. Okay. Now, if you ask me where these images are stored right now, these images are stored on a public repository, which is called the Docker Hub. So this is like a public repository for all the Docker images, which is like, you can say, GitHub of Docker images. Okay. So we will pull this image most probably from there if it's not present on the cache. Okay. Now what I need, this is like an empty operating system, right? I need to install something on it, correct? I need a Python 3 because that's what I work on. APK is my package manager for Alpine, which is like app for Ubuntu. So let's add Python 3. What else I need? I need a pip because I need to install py3 pip. Okay. What else? Let's copy our current code. Copy is actually again a keyword. Copy current dot means the current directory, and I will copy it into the home directory of the container. Okay. Then I will set my work directory to /home because that's where I would be running all the commands now because that's where my code is. Okay. Now I need to install the Flask, right? So pip3 install -r requirements.txt. Hopefully the spelling is correct. Okay, this will install the Flask onto the container. And what else? We need to run the server, right? Entry point. Entry point is something which is always run when you start a container, right? So when this image will be built, this is still where the image building will work. And this command will be run when I will start the container. Okay, I just need what? Python 3. And I just need a run.py. I think we have a run.py, right? Yeah, run.py. Okay, great. Let's save it. We have a Docker file. Yes, we have a Docker file. And now let's build it. So how do we build it? Let's do Docker build. -t is the name you want to give the image to. I will call it Flask. And then dot means find a Docker file in the current directory. And the name is, since Docker file, you don't have to specify the name, and the dot is the current directory. Let's run it. So now it's installing the Python 3 on the basically building an image. And it's installing Python 3. Okay, it has installing. It's installing py3 pip. It's setting the work directory. It's installing the Flask. Okay, and then it's just setting the entry point to Python 3, and then it has just build with the Flask, and the tag is latest. Okay, now let's check that whether the image is built or not. Docker images is the command. Okay, we have a Flask. It was built 16 seconds ago. Alpine 3.7, it has pulled, or it hasn't pulled. It was like already present in my machine for like, I don't know, 19 months ago maybe. But this is the size of the image, and this is the image ID, which is any unique ID which Docker assigns to it. Tag is latest because this is the latest image, and then this is the name of the image. All right. Now, how do I create a container from it, right? So you just do nothing. You just run the image. Okay, it's saying Python 3 dot not found. Okay, let's see what mistake do we make. Okay, we have a dot here. These are things called comma separated. Cool. Let's build it again. Docker build -t flask dot. Awesome. Now let's run it. Yes, we have the thing running inside a container at the port 8000. Now, which container it is get by Docker ts. It lists your running containers. So this container ID of this image of this command was created 12 seconds ago, and it's been up for 11 seconds. And this is a random name which Docker has assigned to it. Now I should be able to access it, right? And this is like 8000 port, right? And it's running on my local, I suppose. So let's access it. Curl http 27.0.0 no 0.0.1 8000. Okay, it's not connecting to 8000. Why? Let's look at the process that are running, right? I have something running on 22, which is my SSH server, makes sense. And on some system thing is running on 53, and 22 is this via IP6 thing. I don't see anything running here on 8000 port. It should be, right? Because like if something is running on 8000, it should be here, right? Let me show you. So, okay, it's my, oh, something slow. Okay, when I run python run.py, and then when I check the netstat, I see something running on 8000, right? On my local, that's I was able to curl it before. But when I run it in the same thing in the Docker, it's not here. Okay, and the reason is the same thing. Container are isolated process. That process is running inside the container. There's no way it can interact with the outside world. So we have to explicitly connect it so that it can communicate with the outside world. How we do that? That we do with the help of basically port forwarding, right? We specify that my outside, let's say 3000 port needs to be connected to the containers inside 8000 port on which a Flask is running. And then I just specify the name of the image, run it. Now, if I check the netstat, I see something running on 3000. And this is my internal port that is connected to the 8000 port of my Flask application inside the Docker container. Now I should be able to curl it on 3000. Yeah, now it works. So that's why the containers are isolated. They have everything running here. And if I look at the Docker, let's just stop this container and then let's see whether the container is killed or not. Yeah, there's no container running. So everything is clean. Nothing is polluted on your operating system. Everything is fine. Now, if I want to use this image that we have just created, I need to have it on a public repo, right? We call it Docker Hub. So I have only one image here, which is very old, I think 2 years ago. Wow. I'll push this image there so that I can access it inside Kubernetes cluster or whatever place I want to be, or if somebody wants to access it, right? How we do it? Let's get Docker images. Yeah, here's the image. Okay, so now we're going to do is we're going to tag this image to some certain name so that we can push it with that name. Docker tag this image ID. Let's call it my name and Flask. We have tagged this image, and now we can just push it to the Docker Hub. Ankur/Flask. Image analysis with the tag of Ankur/630. Oh, okay, it's Ankur630. My bad. It got pushed with Ankur630. I'm not very much sure about it. It might get pushed. Yeah, it's getting pushed. Great. So now it's pushing it. Okay, yes, of course, it won't get pushed because I'm Ankur J630 with the my uh, basically, and what do you call it? My name is Ankur J630 on that, so it won't get pushed to the Ankur 630. That's username is taken by I think somebody else. Okay, Ankur J630 slash flask. This should get work. Hopefully. Yeah, it's getting working. It's pushing it. Great. So it should push it. Just wait for some time. Oh, great. It pushed. So let's refresh it. Here it is. Few seconds ago, this is the image. Yeah, this is the image. This is how we pushed it last time, and we can just pull this image with this name. Now, if you're asking like, how do I log in into it? You could just do a Docker login, and then it will authenticate. I think it's already authenticated for mine. Yes. Otherwise, it will ask you for a username password, and then you can just put whatever account you have for the username and the password, and it will just push it to that machine. All right. So this is what the, like, you can say basics of containerization is. You can container it with just a Docker image. You container it, you push add it to an image, you can run it, and then you just push it to a public repo where you can use. Generally in companies, people don't use public repos. They just have their own private repos, repositories. I personally prefer GitLab registry, and there is, I think, also Google's own registry. Now Amazon is also providing it, so you can use, even Docker Hub has their own private repositories, so you can just now basically people push on that. These are just public things. You don't want to put your important code on public repo. Never do it. Okay, so yeah, that's it for the Docker. Now we can have questions.
I think there is one question. If you click on questions,
Yeah.
yeah.
You mentioned a container is OS independent and all the OS libraries will be present in the base image. Yes. So if my dev server is Ubuntu, yes, and my container image also is Ubuntu, won't it take extra space? Yes, it will take extra space. Yes, but see, the point is it is independent of your operating system, right? So maybe you have both have Ubuntu images, like you have an operating system which is Ubuntu and your container also is running Ubuntu, but that image is completely different from what your actual operating system is, right? That container image is just like a binary representation, and it's required, that thing is required by the container runtime engine to run it. So yeah, definitely it will take extra space. Yeah, that Ubuntu will be different. We can actually, I can actually show you. So this is also Ubuntu, right? So let us pull Ubuntu. Can we pull Ubuntu? Yeah, we can pull Ubuntu. Okay. Okay. Yeah. So we have Ubuntu. Ubuntu is like 72 MB. So they have reduced the size. Okay. So this is this is completely, this is the image for your basically Linux containers. Okay. It is exactly Ubuntu. I can get into it. So let's get into it if we can. Ubuntu. Yeah, I can get into the Ubuntu. This is like a Ubuntu, right? I can, maybe I should be able to, maybe I should do app update. No, like that. Sudo app update. You don't have a sudo in it? Okay. Yeah, you don't have a sudo in it because this image is completely different from your normal machine, but it behaves as a normal Linux container. So yeah, you can upgrade it as well. And I don't want to upgrade it. I can just exit this. Yeah. So is that question solved? Like, do you have any other doubt on that? The same thing. Okay. Can we check the size of the current Docker image? Yeah, sure, you can check the size of the current Docker image. You can just do Docker images. And my Flask image is 61 MB size. my Ubuntu, which I pulled, was 72 MBs. Alpine is just 4 MB image. That's why I prefer using it. It keeps the size very low of the main image file. Because if I was using Ubuntu for it, the Ubuntu is only 72 MB. So think about after Python and everything, how huge it would be. And then it takes time to push and pull. You can see the size here. Okay. This
Oh,
is where all the sizes are. So yeah, you can see the size.
okay. I hope it answered your question, Vivek. I'm just moving it to answered.
Where do we need to give our build and start commands in Docker image? No, you don't. No. So you don't give it into the Docker image. One second. Let's just check it out. When I think I lost the connection. There. Oh, this is working fine. With this shell is broke. Let's use this. Yeah. So this is just a way of telling the Docker what to do. Okay. If you want to build it, you just do a Docker build command that I want to build with this configuration. I don't know, let's call it flask one. I want to build with this name and with this current configuration, which is present in the Docker file. And the run command is given here. The entry point is the command which will be running when you will start a container. It will not be running when you build the container. Building is still here. This is where the build works. And then this is where the run is executed when you actually run the container. This is building the image. This is running the container.
I hope it answered you, Nitin. I'm just moving it to answered,
Yeah,
right?
if you have doubt, you can, yeah.
Okay, yeah, great. Okay, there's one more question from Ajit.
Yeah. Can we run Windows container in Linux machine? Okay, this I'm not very much sure of. I have always worked with Linux containers. I've always worked with the Linux containers, and so you can run Linux containers on. I think you can run if Docker is supporting. Docker says that if you have a runtime engine available on a machine, then it doesn't matter which your container is and which your operating system is below. But I ran into issues where due to some mismatch in the Linux kernel, some of the containers doesn't work. And that thing exists in the Linux world. I'm not very sure about the Windows containers. Frankly speaking, I never built any Windows container ever in my life. I don't even know much about it. So that I might have to research. Windows I've never worked with. Sorry about that. Yeah.
Okay. Ajit, you can anyway reach out to Ankur. I'll anyway share his link,
Yeah.
and you can reach him out there. Even like you can join our community, backend community, which I've shared the link. So even you can ask the same question there, and I think someone like maybe if not Ankur, then there would be someone else who can answer this question. Okay, I'm moving it to answered right now. So there's a question from Saket.
Can you please explain briefly the layering on the basis of commands in Docker file? Okay, sure. Um, so, one second. Yeah. So the way it works is you have a base image, which is like the Alpine, and then what happens is you keep on adding layers to it, right? So even what can happen is I can actually use this same, I can create multiple base images. Okay, so let me remove this. Let's say this is my base image. I have few layers on it, and then I have requirement.txt installed. Okay. Now let me just close it. Okay. Let's build this image. Let's call it Flask base, and let's build it. We're not running anything. We're just now we're creating another base image for, let's say, some different project. Okay. So this image is built, and each and every step that you see is a layer. So this is the base image. This is the second layer, third layer, fourth, fifth, sixth. Okay. And then you keep on adding to it, and then you get the final image, right? And now I will try to use this same image as my base image. Okay. Uh, let's go somewhere else. Let's mkdir sample Docker file. So oh yeah, I can use, yeah, latest. I will pick the latest. So now I can use another image as my base image, and then maybe now this already has Python installed and pip also installed. So maybe I can now install something else. Pip3 install minus r requests. Okay, and now I can build this as well. This was a Flask base. This is, let's call it it's a Flask install, and let's call it the Flask request. So now this is able to install no such file. Oh, sorry, my bad. Default habits. This is getting, so this is already has pip3 installed because I was already using a base image before which had a pip3 installed. So now I'm able to install request directly on it. And now if I look at Docker images, I have a Flask request. Now if I go into it, okay, the command which I'm running right now is called docker run minus it, means interactive. Just keep connected to it when whatever now I'm going to do. Then I give it a name of the image, which is Flask request. And how I want to make that stable connection is through sh, which is the shell. Okay. And so this has already components before because that came from the base image. And I should have a request library here. Import requests. Yeah, I have a request library here already. And because we build it from another base image, or now you can use this base image to maybe use it as a base image, add more to it, keep on adding more to it. A lot of people do that. Initially I was working on I need a base image with Python and I think Nginx with it. So that's my base image. It has Python 3, Nginx, everything inside an Alpine machine. And I build on that, and then you can keep building on that. That's how basically layering works for Docker. Yeah. I hope it answers your question.
Okay, I've already moved it to answer.
Okay, great. So
There's one more question from Keshav.
can you please? Okay, this is the same thing. Can you please tell how Docker and Docker Compose are different from each other? Good question. So Docker and Docker Compose. It's Docker Compose is basically to sync multiple containers with each other. Okay, so when people say Kubernetes, then it's like more of like you can say it's an orchestration system. All right, it kind of go into the same category, not exactly the same category, but Docker is the underlying technology to build the containers, and Docker Compose is a technology which helps you run those containers in basically a production environment. Um, yeah, basically helps you run those containers in a production environment effectively. That's the major difference between both. Docker is a technology for building the containers, and you can just run those containers individually. But Docker Swarm gives you the capabilities to basically manage those containers in a production environment, just like what Kubernetes does. They all kind of fall in the same category. Yes, people prefer Kubernetes and Mesos because they are not dependent on the container technology. Docker Compose is dependent on the same container technology. That's why it's called Docker Compose. Yes.
Okay, I hope it answered your question. I'll just move it to answer. Okay. Do you guys have any other question like in this demo? Okay. I think we can go ahead with the presentation now, Ankur.
Okay, great.
Yeah.
Okay, so now, okay, so let's start with the next topic of why do you think we need an orchestration in the first place, right? Kubernetes is an orchestration platform, correct? And the question arises that why do we need it in the first place, right? So let's look into that. Okay, so assume that you're running containers in a production grade environment, correct? And now the same thing problems happen, right? You have to manage the containers. You have to make sure that all the containers are running up 24/7. If one of the container is down, then another container has to start up. And then the problem is that the container doesn't talk with each other, like we see, right? They're isolated. But if you are running containers, you're most probably going towards a microservice architecture, and then you need the microservice to communicate with each other, right? And you have to explicitly connect them then. Okay, what else? Load balancing. Load balancing is a very huge problem. Generally, the load balancers which are provided by your cloud service provider are basically balance the load on the virtual machines. But let's say I have a virtual machine which is running like 10 containers, because containers are very lightweight processes. Then I need to do a load balancing on those 10 containers, right? How do I do that? You can say you can use maybe a reverse proxy server on it, which is correct. I can use a reverse proxy server on it, but I don't know. But then the same thing, right? I cannot access that container unless until I explicitly expose it to the outside world, right? Then only the reverse proxy will work. So basically, you have to manage those things on your own, right? And so basically what happens was people realized that we need a system which has this kind of behavior out of the box, right? And that is the need for orchestration comes in, and that is why the Kubernetes comes in the first place, right? So what does Kubernetes provide us, right? It provides us service discovery. Okay, so let's say you're deploying one of the service, right? Or you're deploying one of the container. Now the container will have an IP on which you can access that container, right? Currently we're working on localhost, so we can just directly call the container, and we just can have the IPs and everything of the localhost, right? In a production environment, when I have like multiple containers running, and it's very difficult to just get to the IP of what the container is, right? So there has to be some discovery kind of service thing which helps me find those containers easily. Correct. That's one part of the Kubernetes. Secondary, load balancing. It loads balance across the containers, not across the nodes, but also on the containers running on the same node. I will see how it does that. Autoscaling. Kubernetes comes with the autoscalers inbuilt. You can tell him at what load you want to autoscale, and or at what number of requests you want to autoscale, right? So Kubernetes provide you that. Desired state management. It is a very, very important part of Kubernetes. The way Kubernetes work is you give him a desired state of your system. You tell him that I need Flasks, 3 pods running 24/7. Now it's Kubernetes' responsibility to make sure that 3 pods of Flask, sorry, pods, when I say, you can assume containers uh, for the time being. They are different. There's a little bit difference between pods and the containers, but let's just assume when I say pods right now, you can just safely assume that they are containers. We'll see later on that what's the actual difference between the both of them. So when you tell Kubernetes that there needs to be like 5 or 3 kind of Flask containers or pods running, then Kubernetes will make sure that there are 3 pods running 24/7. If one of them goes down, it's Kubernetes' responsibility to make the another one come live. Resource management is very important. You can tell Kubernetes that, hey, Flask pod should not exceed 100 MBs of RAM. Whatever happened, I don't want it to exceed 100 MB of RAM, and it will make sure it won't exceed 100 MB of RAM. If it's using more than 100 MB of RAM, 100 MBs of RAM, it might just kill it, or it will not let it allow more MB of RAM. Then I don't know how the code will, depending on your code, your code might choke, or your API server might choke, or depending upon how the code is written. But it will not let it allow more than 100 MB of RAM. Third, easy releases. Kubernetes provide you a good release option, so it doesn't kill all the pods. So let's say you have 100 pods running of a particular service. It doesn't kill all the pods immediately and then deploy again. It kills one pod, the new release gets live, then second, then third, then fourth, and in a rollout manner, all your new code comes live with the production. Also, it provides you with canary releases. Canary releases, yes. What happens is you can tell Kubernetes that, hey, I need 10% traffic for this V2 version of my API, right? Kubernetes will deploy a separate release for that pod, and it will only serve the 10% traffic. So even if something goes down, only your 10% of the consumer might be facing it, 90% will be fine, and then you can immediately roll back that canary release, and you can, the rest of the thing will be served by then it will just shift to the normal code that you're running. It's very good for testing few mission critical, basically you can say APIs on the production server. That is very good with Kubernetes. All right, so let's talk about, okay, Kubernetes cluster. So whenever somebody talks to you about Kubernetes, they are inherently talking about the Kubernetes cluster. Okay, these two terms are used very interchangeably. People say Kubernetes, they're just talking about this Kubernetes cluster, the diagram which I'm showing you right now. Okay, this is a lot of things here. I'll try to explain it. So there are two major parts of Kubernetes. One is called the nodes, and another one is called the control plane. All right. Node is simple. Node is just your smallest unit of computation that Kubernetes have, right? It's that raw virtual machine that Kubernetes has, okay? And you combine a lot of nodes together, you get a big fat cluster, okay? That's it. That's what a node is. It's the raw computation power provided to the Kubernetes. Now, control plane is something that is the brain of the Kubernetes. And if you have heard people say that we have like a master slave relation, master node relationship with Kubernetes, we have a master node and then you have a slave nodes. Generally, people meant by master node is something where your control plane is running, okay? Because that's the brain of the system. That is basically orchestrating all the nodes, containers, and everything for you. Okay, so it has very important part called the Kube API server. Kube API server is basically a RESTful server, which is exposed by the Kubernetes, which gives you capabilities to manage the Kubernetes cluster. It gives you certain endpoints, which you can create a node, delete a node, add containers, remove containers, create services, deploy things, a lot of stuff. All right. And kubectl is the client for it, just like Docker was a client for the Docker engine. Kubectl is a client for the Kube API server. Then there is called the scheduler. Now, you with the kubectl client, you tell the Kube API server, hey, can you start a Flask container, right? And it needs 100 MB of RAM to start. Then the Kube API server will send this request to the scheduler, and then the scheduler responsibility to find a place or space in the nodes to start that 100 MB pod of Flask, right? It will know, okay, node 1 has no space available, node 2 has 100 MB of space available, let me schedule that container or pod on the node 1, okay? And scheduler is very good at optimizing your nodes, right? It won't just spread them out. It will try to pack as many things as possible in one single node, and then it tries to move to the secondary and the third, right? It's very good at those kind of things. Now, I told you about the desired state management, right? So let's say you say that I need 3 pods running off Flask, right? And then one of the pod goes down, or let's say one of the node goes down. The whole V virtual machine is down for certain XYZ reason. Now the Kubernetes has to reschedule the pods, right? Let's say there was only there were 2 Flasks running here, one pod was running here. This one goes down, the whole node. Now Kubernetes needs to move this pod here, right? Because this one is running, and let's say it has space available. How does that's what the control manager does, okay? Now he will tell the scheduler, hey, look, we're supposed to running 3 pods, only 2 are running right now, one is down for certain reason, can you schedule that one pod? Then scheduler will see, okay, node 1 is down, I can't schedule it here, it will schedule it into node 2 is down, it will schedule it on the upper node. And then you still have 3 pods running out Flask. Now the important question is, how does even the control manager knows that one of my pod is down, right? Or one of my container is down, right? That's where this interesting service comes in called the kubelet. So kubelet is basically running on each and every of your node. It's a small service that running each and every of node, and it's getting all the information of all the pods in that particular node. It knows how many pods are running, how are running, at what time they start, and what is their health right now, and keeps on feeding that information to the Kube API server, which transfer it to the control manager. Now, control manager has all this information of what is happening in all the nodes for all the pods with the help of the kubelet, and then it takes those wise decision, right? So kubelet tells him, oh, he was supposed to get the 3 heartbeat messages from the kubelet for pod Flask. It only gets 2. That's an indication that one of the system is wrong, right? Either the whole node is down. If the whole node is down, then the kubelet is not running, or maybe the node is perfect, the kubelet is perfect, but the pod is down for certain reason, right? And maybe you deleted it by your own, right? So it doesn't get that information, and then it realizes, okay, great, something is an issue. I need to reschedule 1 because 1 is missing, and then it store all this information into a key value pair so that it can access it easily. That key value pair is called the etcd. It's just a key value pair for the control manager to store the information there. So this is what Kubernetes is, right? This is like the base thing of Kubernetes cluster. Okay, and when somebody talks about Kubernetes, they're inherently talking about this cluster, right? There are more internal things to it, which we might cover in later sessions, like the networking. But currently, for the starting point, this is what it is. And um, yeah, that's it. This is what majorly the Kubernetes cluster is. Um, but these are the things which you might not see in your day-to-day life, right? You don't have to care about the control plane, nodes, kubelet, API servers, or anything. You just care about the kubectl. You just send the commands to the kube API server, and these things just like work like magic behind. You won't interact with them in your day-to-day life, but we will see them in action. All right, so I would love to see them in action. So let's see them. Okay, let's create a Kubernetes cluster. Okay, so I prefer DigitalOcean. You can use any cloud service provider you want. Google, I think Google give it free. AWS is kind of costly, I suppose. Okay, so can I start a cluster? I don't. Oh, okay, we need to create a Kubernetes cluster. Okay, where do I want it? Let's choose Bangalore. Yeah, I want it in my same VPC. You have, okay, I don't have, I think, limit. Let's reduce it to 1 node. Can I do 2? No, I don't can do. I don't have a limit for it. Okay, this is the pool. So this is like, this means that I'm just using a basic node, and I will have a single node, and that node will have a configuration of, let's use cheaper ones. It will have a 1 gigabytes of RAM, and it will have 1 gigabytes of RAM. Yeah. And let's give it a pool name. Pool name is basically the name of this kind of pods, right? So I can call it pool 1 GB RAM. I can add additional pool, and this time, let's say I can select, maybe this is single core CPU, this is 2 CPU, so I can 1 CPU, and this might be pool of 1 GB RAM, 2 CPU cores. Okay, and this might be like, this might have like maybe 2 nodes, or I don't know, 3 nodes, but I don't have enough limit, so I will just use single node. My bad. Okay, this is like the monthly charge, which is fine. Any tags you want to add, name you want to still, I don't know, Kubernetes 1.1. This is like Bangalore, I don't know, test. Let's call it test. And then, yeah, I think that's it. I have a cluster capacity, which I've specified, and I have just chosen a name. You can just start it. I don't know how much time it will take. Yeah, it will take some time to get started. Yeah, we have 2 gigs of RAM, 50 gigabytes of storage space, but that's fine. It might take some time. I already have one of the cluster which is running. I call it, like, on my jump machine, I have like a jump 1 cluster which is already running. This is like similar cluster. We can have a look at this. Okay. I think I might have. This is pod, I suppose. Okay. So you can just install kubectl. It's a standard kubectl command. And if you come here and if you look at, I don't know, I think I've already done this. So I can, yeah. So this is how you authorize your kubectl command with the Kubernetes API server. So they give you that. You can easily just run this command on your machine and it will get authorized. Mine is already authorized, so I can just call get nodes. Yeah, and this give me, this is this pool name which you will see here. If I go to nodes, I might have I have a master pool running which have only single node running. So this is that node. You can get the information about this node. Yeah, so okay, this might not be very good with this. Okay, so this gives you a few information like memory limit, internal IP, the container runtime version. We're using Docker 18.9.9. The operating system is Debian, GNU Linux. It's running on AMD, and there's some boot IP. There's some how many CPU and storage is there. Some health checks that disk pressure is no disk pressure on the kubelet. Kubelet is telling you that there is no disk pressure, and other information. What more do we have? It gives you lots of things. Most of the things you might not require. I'll give you the name and other things. Okay. This is there. If I told you the service that I told about, so let's describe this. We will go to service later on, but I want to show you something. And this is where your API server runs in. So this service is what your Kube API server is. And this have an internal IP, and this is running, this is listening to port 443, which is the SSL port. That's why we need to authenticate it with the kubectl. Otherwise, it won't allow you to access. Okay, so, and most of the things I can't even show you because I think DO doesn't give you an access to go inside the node, like for the kubelet and other things. So I can't show you those. But basically, this is what we can show right now for the Kubernetes cluster. And frankly speaking, you won't be interacting with these things in your day-to-day life. You won't. This is just the back end of the Kubernetes, right? What I want to really talk about is the cool stuff now, which you would do in your day-to-day life, which is what you will do to manage the Kubernetes cluster, to deploy the code on the Kubernetes, to make sure that it's live. And we'll talk about that. But before I start with that, does anyone have doubt in this Kubernetes cluster thing? We are open to questions right now if anyone has a doubt for this thing.
Okay.
When does a container dies or goes down? Okay, the container goes down for a lot of reasons. Let's say you put in an image which is not available. Okay, your container got choked, right? You put so many requests onto one single container that it's not even able to handle the request, and your code goes down. If your code goes down inside that container, then what's the importance of the container anyhow, right? So when you start a container in Kubernetes, you tell him that this port has to be running. Something is running on this port. Please check whether this port is active or not. Let's say you're running Flask, 8000 is down, right? So now basically the container is dead for it, right? Because there's nothing running in it. There's no process running inside the container is dead for it, right? So it might be an issue with your code, or maybe you get an error and you don't handle it gracefully and your whole Flask code is down, then the container is down, right? Sometimes it's RAM issues. There are a lot of things, but most of the cases is generated to code and not not like the infrastructure scenario. Okay. Can you help me with a scenario where RAM of container increases, in production? Yeah, maybe you're doing something RAM intensive, or you have an Nginx proxy running on inside your container, and that Nginx proxy uses RAM for caching the request or something, and that RAM immediately shoots up. That might be one of the case. Or you are reading a huge file from S3 or some storage into RAM, and you're trying to process something in it, and you use all your RAM because you read a very huge file into the code, and that's how your RAM will shoot up. So yeah, those are two very general cases which happen when your RAM shoots up. Or some, maybe you have a lot of requests and you're not and the API server that you're running, like Gunicorn or something, that keeps current running requests in the RAM, and then the RAM shoots up. So your RAM will increase in that regard. Yes.
I'll just move it to answered.
Yeah, you can move it to answered if it solves you. Otherwise, you can put the question again if it is not solved. Yes.
Okay, I hope it answered your question, Keshav. Just let me know in the chat section so that I can just keep it.
Okay, there's one. If control plane goes down, node pod also go down. Then how you can make active? How can you recover service? How will you make sure that my cluster is up in condition? There would be no zero downtime. Okay, so if the control plane goes down, that's control goes down, node pod also go down. If pods are down, is when if pods are down, then we don't have an issue because control plane will manage it, right? But if one of the pod goes down, then of course there is a downtime because the Kubernetes cluster will detect it. It will schedule your new pods in a certain node, right? and let's say you have no running nodes right now apart from your master node, then all the containers can't be scheduled. So generally what we do two things in this scenario. First, we give the Kubernetes the power to start a node, right? We tell him, look, you have two nodes running, which is fine. I'll give you three access to three more nodes. Don't start it unless until you need it. Okay. So let's say those two nodes go down. Kubernetes have the access to start three more virtual machines, and then it will schedule your pods there. Okay. But you have to give it to them explicitly. Google Cloud allows it, AWS allows it. I don't know whether DO allows it or not. But I've worked with GKE and it worked beautifully with Google Cloud Kubernetes engine very well. Now, if your control plane goes down, that is very difficult because it's running on a certain node, which we call it the master node, and it's very much protected. I haven't seen any condition right now in my production cluster where my control plane is down, because anyhow you don't change those services, right? Those are running in a separate namespace, which we will see in a moment. But those services are running in a separate namespace, and you don't explicitly basically break them or something like that. So yeah, it's very difficult to get a control plane down. But yeah, if your nodes goes down, then you can give the Kubernetes the access to multiple nodes. Just ask him don't not to start it, and it will start it when he needs it, and then he will just close it later on. Yeah, I hope that solves your question. This will make sure that your cluster is don't have any zero downtime. Yes, this will make sure that. Yes.
Okay. So, Ajit, I'm ready to answer. Let me know if
I
it's
hope
not
it's
answered or you didn't get a clear answer. You can raise your hand and then we can discuss this. Otherwise, after
yeah.
the
We can
session,
discuss this definitely.
yeah, after the session, you can connect with Ankur in the social launch and you can discuss this.
Can
Okay.
we create multiple control plane? No, control plane is something which is managed by Kubernetes. If you are having your own Kubernetes setup from the scratch, which I won't recommend because there are tons of things, then maybe you might do it, but it's generally it's one single control plane which is running on the master node that we call it. Whatever node it is running on, we just call it a master node. And it's only going to be one. It's not going to be, there's only one is needed to manage. There should be only one brain, right? I don't know. There are two brains, and I don't know. Like nobody wants two brains inside a machine, right? One brain is enough. Yes.
Okay, I'll move it to answer then. Ajit, like if it's been like answered your question. Okay.
Okay. Can you show load balancing? How to put Docker container inside Kubernetes node? That's we're gonna see just in a moment after this. The cool stuff is that. Okay, that is the really cool stuff. That how do you put it inside and how do we access it? That's where the cool stuff is. Let's keep it here. Question for the time
I'll
being.
keep this question.
Yeah.
Ankur, like if you can just refresh it, I think
Yeah.
so that we
Sure.
both will be on the same page.
Okay, when a cluster scales up, then how does the load balancer knows that new node or VM is added so that it can route traffic to a new one? Good point. So when a cluster scale ups and you had a new node, right? That node is requested by the control plane. Okay. And that node is requested by the control plane. And that's how we know that a new node is added, because somebody has to request that new node from your cloud service provider. That is done by control plane because it knows that it requires more space to do it. How does it route the traffic to the new node? Is with the help of a component called kubeproxy. Let's hold on to that. We'll talk to it. We'll talk. I think in like I think 20 minutes we will talk about it. But let's just hold on to that question right now. I'll explain how it does happen. Sid.
I'll
Okay.
keep this question as well.
Yeah, I think there are lots of questions which are coming from the next segment.
Okay.
Okay, there are a few things which I can do. What is it? Okay, this question is load balancing is fine. Docker inside, this is fine. This is fine. Okay, there are two questions. How do you calculate the max request count for for Docker? You don't do that. That's a very interesting thing. Kubernetes does it for you. You can. I'm not covering it here because it would have stretched it too long. You can just go and Google Kubernetes HPA. It's called the Horizontal Pod Accelerator, and then you can specify it at which how do you want to scale the pods depending upon certain parameters. Generally it works with CPU and RAM consumption, but you can also depend it on the load, not the request count, but generally on the load. You say that after 60% of the load of the traffic increase, I don't want it to be handled more than 60% of the traffic, right? Or 70% of the load. So the moment your consumption goes more than 70% or 80%, it will start a new pod for you. And there are few systems available which also helps you calculate the request count, and then you can manage it based on that. But generally it's done by Kubernetes. You don't have to do it on your own, because the traffic is split on multiple pods, right? So it handles it for you. I hope that answers the question, Sahil.
Okay.
Uh,
I'm moving this to answered. Sahil, let us know like it's not been answered. Okay.
what is the difference between load balancing and autoscaling? Okay, load balancing means transferring the request to different nodes, right? So load balancing means, let's say, it's generally Kubernetes do a round robin load balancing, right? So I have 3 flasks running. One request comes, goes to one pod, second to second, and third to third. Then fourth will come to one again. So you're balancing your traffic across the multiple, basically what you can say, pods, right? Auto scaling means, the problem is I got I got huge requests somehow. So when Narendra Modi just came on the TV show and then he says that today we won't be like note to band ho gaye hain, right, 1000 rupees wale, right? So what happens, one of my friend works at NDTV and he says that we got such a huge spike at 8 a.m. and Modi was giving speech, that whether it's correct or not, that it's their auto scaling cluster, because your current system is, let's say, dependent on 1000 requests per second, and then immediately one day Modi ji comes and then you find out, okay, fuck, now it's like 1 lakh people is accessing my site at 1 cm time. Then you need to scale your cluster, right, so that you can handle more requests. Then this cluster will scale, and then internally it will be load balancing across multiple systems that you have scaled on, right? So scaling is adding more resources, and load balancing is just balancing it on the current resources that you have. Okay. Can we schedule the pod inside the control plane? No, you should not. And no, you should not. And you can if you have like the full access, but you should not. They are present in a completely different namespace, which I will show you in a moment. But you should not. You should not do that. You can, but you should not. And control plane is nothing. It's just like a namespace which is comprised of 2 to 3 things. It's not like there's actually a control plane present somewhere. They are just we just call it like a abstraction layer we have given them to the 6-7 components. Okay, so these 6-7 components are definitely present in your machine. They're running in 1 or 2 places, but the namespace or by the segregation that they're running on, just don't go inside their segregation and basically do something inside it. It's similar to what you call like a Linux root area, right? Don't just go out your home directory or certain directory which you have like mount and opt. Just don't go around and change some root things. So that those things are managed by Kubernetes. You don't want to go there. Kubernetes gives you your own personal space, that this is what you manage, this is what I manage for you. You can, of course, but I won't recommend it. You might break something for some, and then you have to maybe restart the whole cluster and other things. So I won't recommend that.
I'll move it
Yeah,
to Ankur.
yeah,
Hope it
I,
answered as
yeah.
well.
I think we can also solve. We also solve the load balancing and auto scaling thing.
Okay.
The last one. And
Okay.
does K8 has load balancer within its infra, or we need? Okay, does K8 has a load balancer within it infra, or we need to set up a load balancer explicitly? So K8 has a load balancer inbuilt for the infra. Yes, K8 has a load balancer inbuilt, but generally we set up an external load balancer for services to access. So if you want something to be accessed outside the Kubernetes cluster, then you need a load balancer generally. But if you don't want something to be accessed, if it's completely, the cluster is self-sufficient in itself, right? Everything is inside the container, then you don't need an external load balancer. It has its on its own. It's called the kubeproxy component. That is the thing which is handling your load balancing for you. But if you want something to be accessed from the outside, then yeah, definitely a load balancer is very good, because you don't want to expose your cluster's IP to the outside world. That's not a good security thing to start with. Okay.
I hope.
I hope that helps. Yeah.
I think he's only sending the thumbs up.
Okay. Where does the Helm charts fit in? Helm charts is something which is like pip for Python, npm for Node, or apt for Ubuntu. Helm chart is a package manager for Kubernetes. I was gonna add Helm charts to it, but then I realized it's too big. Helm chart is a package manager. It's like you can do just Helm install whatever component you want for Kubernetes. Kubernetes comes with a lot of components. You might have a look into that. It's similar to what you do with Python. Oh, I need Flask, pip install Flask. And same thing of the Helm install Nginx controller. You get a Nginx controller for it installed on your Kubernetes. You don't have to set up it from the scratch. That's what the Helm comes in. It's a package manager for Kubernetes.
Okay. I hope it answers, Siddharth. You can just say thumbs up. I'll move to answered.
Yeah. Can you show load balancing? This we have to do. Docker container, how clusters set up, scale up, and how does the load balancing know that? Okay, cool. We have 3 questions left, which we will
Okay.
just cover in the thing.
Okay.
All
I
right.
like if anyone else have any question, you can shoot right now, or else we can just move it to the
Yeah,
presentation.
we can just take it at the end of the
Yeah.
webinar. Yeah.
Fine.
Okay, now I want to talk about interesting stuff. This is something which you would do in your day-to-day life, and this is what we used to do in our day-to-day life when I was managing the Kubernetes cluster. So yeah, first thing is called a namespace. So namespace partition a single Kubernetes cluster into multiple virtual clusters. So basically, these are separate clusters inside the main cluster. There's like a separate logical barrier to system, which is like what a namespace is. Okay, so let's say I have a namespace default foo bar. Generally, why we need namespace is because so sometimes what people do is people have a big huge cluster and then they just add their development, staging, and production in 3 different namespaces so that they don't interact with each other, and they don't just and then they give access to 3 different namespaces to 3 different teams or maybe 3 different individuals, and those basically users are restricted to that only namespace. So you cannot just go into somebody else's namespace and then remove a pod or something like that, right? You can't do that because you have your own namespace and there's one huge fat Kubernetes cluster running, which might be managed by some infra team, and you just give access to 3 different people for pod development and maybe production. That's how you have 3 namespaces. Okay, there are few namespaces which Kubernetes manage on their own, which we will see. And the best implementation, I think, I don't call it the best implementation, but the way we used to do it was we used to have different clusters for staging and production, and then we used to have different namespace for different teams. So development team have their own thing, then a marketing team used to have their own cluster where they can run whatever things they want in there, and then data analytics team used to have their own cluster. Okay, so different teams have different namespace. Sorry, some one cluster, different namespaces, and then you can do whatever you want in your namespace. Just don't go and enter into my namespace. They won't have it. Kubernetes has role-based access. Kubernetes has it. You can start a namespace and give it a role-based access, and then only those people would be able to access it, which have that role. And so that's the basic thing for Kubernetes, different namespaces. Default is something which comes by default out of the box, okay, which we'll see, which will run most of the things right now for the time being. Secondary thing, pods. Okay, this is very good. So when I say that you run your containers on Kubernetes, right, the Kubernetes doesn't run your containers directly. It wraps it inside a higher level, you can say, structure called a pod, okay. A single pod can have multiple containers running if you want it, and those 2 containers assume it as like a single machine, right? They're like a part of a same machine. Generally, what we do is generally we run single container, a single pod. I have not. Uh, I've done it, but I've never done it in production. That I'm running. We are running 2 containers in one single pod. Maybe you might find a use case where you can. We didn't find it any use case where we have to do it. But yeah, so the reason why they wrap it inside a pod is so that Kubernetes can manage that pod easily. Containers are some third party, right? Maybe it's a Docker container or Linux container. How would I know? It's a Docker container, right? At the end of the day, we are using. So pod is something which Kubernetes can manage easily. That's why I say we can use pod and container interchangeably, but it's a higher level thing on the containers. And generally, you have single pod, single containers, and you can use them interchangeably. Doesn't matter. But if you have two, then you should not use pod and containers interchangeably. Okay, deployment. Now, we generally never create a pod on Kubernetes cluster directly. We use something called deployment. So deployment is a desired state of management, right? It's like this huge configuration file. You tell it to Kubernetes and just tell him, boss, this is something which you need to maintain, and this I just want you to maintain it. Okay. And this deployment generally have like how many pods I need and what is the RAM and CPU of all those pods that I need. Okay. So let's just cover this much first, all right, and then we'll move to the few other things. Okay. Okay. kubectl get pods. No pods running. First, let's check the namespace. kubectl get namespace. Namespace. Okay. So default is mine, which is like not mine, but it's like the public thing which you can use. Then there is like kubepublic, kubesystem, kubenode releases. Okay, these few things are started by Kubernetes. It's managing it. So I don't want you guys to just like, you can look into it if you want, but like these things are doing. Let's know what kube system is doing. Kube describe service kube system. Kube serial DESCRIB. But it's not a service, it's a namespace. My bad. Kube CTL get pods minus namespace. I think if I'm correct, I'm not remember the command exactly, but this should, yeah. Okay, so this is giving the pods for this particular namespace. By default, it gives you for default. So when I run this names, whether you type default or not doesn't matter. It gives you for this. This is where the different things are running. This is where your Cilium is running. Core DNS is important. It's a DNS registry. I'll talk about it. Kubeproxy is very important. We're going to talk about it. There's some node agents and some other stuffs which Kubernetes is running. Like the Cilium thing, I'm not very sure about it. It depends from cluster to cluster. I think DigitalOcean runs it. I have never seen it in GKE. So it depends on different things. There's kube system. What more do we have? Kubepublic. I think Kubepublic is something which they added in just few things. It might have nothing running. Yeah, it's just a public namespace where anything can. It's just like a way of saying this thing can be used by anyone can come and look into it. Something like a public repo or something like that. Okay, then let's see the deployments. So there's no deployment in the namespace. Now let's deploy the thing that we created, right? I will just do a deployment. Cool. So this is what a configuration file looks like for Kubernetes. Everything is a YAML in Kubernetes sense. Okay. So this is an API version. I told you that Kube API server is a RESTful API server, right? So this is the API version of that thing. We are trying a deployment of a kind. So kind is the keyword, kind, and deployment is actually the keyword. That this is a deployment file. This is a deployment file. Name of the deployment, let's call it a Flask app deployment. How many pods do I need? This is a getting system. I need only, let's say, one pod. Okay. Selector match labels. Okay. Now I told you, right? How does the deployment know that two pods needs to be run for this kind? This pod is this type, right? Control manager needs to know, ki, boss, you asked for two pods of type A. What is that type A thing? That is this label, right? So this label Flask app will match with the label of the pod. Okay, so it's asking you, what you're telling him is basically, please match this label Flask app, and this is a template for the pod. इसके नीचे सारा pod का template है, इसके ऊपर सारा deployment का. Okay, so we are just now telling Kubernetes that this deployment will be looking at these kind of pods. Okay, and only one of the pod has to be running. And please look that whether the Flask app kind of pod is running or not. That's the type of the pod that they specified. And then we have just say this is the pod which have a Flask app. We just written it here, and this will match this. Then we have specified containers, because two, but we are only running one. So container name Flask, image Ankur 630 @Flask. That is the same image that we have here, right? So we're going to pull that image. Image pull policies, every time you start a container, you should always pull the image. Don't use it from the cache. That's what it's mean. Okay, container port. This is interesting. So this is the port on which your application is running. All right. For our sense, it's running on 8000, right? We look before, right? The Flask is running on 8000. So this is that port. Okay. The internal port of the container. Then resources. Okay. I've asked the Kubernetes that it needs minimum 100 M of RAM and 50 millicores of CPU. Okay. And its limits are, should not exceed 100 millicores of CPU and 150 MBs of RAM. Okay. This is the resources that you always specified. You should specify when you're starting a container. Okay. And this is the container port. This is the image pull policy, name of the image Flask. These are the containers. The one of the container inside the pod of type Flask app, and the deployment will make sure that the Flask app kind of pods are running. Only one of them is running. Okay. let's try this one. So how do you run it? kubectl apply -f and give it a file to run it. Okay, kubectl get deploy. So nothing is ready right now, so we can actually pods. This is a container is creating right now. Now the container is running. Okay, it was creating first, now it's running. It's been running for 12 seconds. We can look into this container. kubectl describe pod. Okay, so you see it's successfully assigned. This is the name of the pool. So it's got scheduled first. That's where the scheduler comes in, right? I told you. The scheduler has to, default scheduler is the scheduler which you're using. The scheduler has to schedule this thing. So it finds a pool for it, a node for it. It schedules it. Then it starts pulling the image. It was able to pull the image correctly. Then it created the container and it started the container. Okay. If something happens, this will not work. Okay. Maybe we can try this. Let's change this image. I don't know. I don't want. I don't have anything called Flask ABC, right? I don't have anything called the Flask ABC. If I now apply it again, this is configured. But now let's look at the pods. So the old one is still running, right? Because it can't just kill it unless the second one is live. But this one didn't get live. Okay. So that's why the old one is still running. So this makes sure that even if your new one fails, the old one, it will not kill the old one till your new one starts up, right? Now the issue is giving us is called the error image pool. It was not able to pull it. Let's see it. Yeah, it was assigned. Then it was trying to pull this. It couldn't. Then it tried again, and then it didn't was able to pull it. So this container was not live. Okay. Now we don't need it. So kubectl get pods. Yeah, let's just remove this. Yeah. It started one. Okay, now it's trying to remove it and it's trying to create another ones again. Because it's trying to run this again and again and again. It will eventually, yeah, it will eventually get over with it, and then it will just not do it. But that's fine. We'll just update. Generally, because the deployment needs to be correct when you're running it, because otherwise just keep on deploying it. So now you did it. See, now it's started another one. Now it's removing that because your deployment configuration is fine. Okay. So let's say I need 2 of the pods, right? So let me just make it 2. Now it will start another one, right? And if you look at deploy, it will say 1 is ready. 1 of 2 is ready. 2 by 2 has to be there. When it got 2, it will say 2 by 2 is ready. Now let's try to remove a pod, right? Because the configuration has to be maintained, right? This one was running 16 seconds ago. So this was terminating and then it started another one. Because you asked for it to be 2 by 2, so it will just make sure that there are 2 pods running, right? There are 2 pods available and there are 2 pods running. This will get terminated eventually. So yeah, so that's how you create pods, right? And that's how we have created our code into it, right? Now let's see things. kubectl get, sorry, let's describe the pod. Now, how do I access it? It must have an IP. Yeah, here's the IP. This is the IP which is private to the cluster, right? But I should be able to access this inside the cluster, right? Now, how do I access it inside the cluster? Let's just copy this IP. right? Yeah. So I need something. I cannot just curl it right here because what is the port? 8000. Nothing will happen because this IP is local to the cluster. Okay. So what I need is now I need to get inside the cluster. Okay. So or I need something which is running inside the cluster and then I can access it. Okay. So we'll do the same thing. We will just run. So we are talking the Kubernetes to execute this command, which is like -it is the same interactive shell. --rm means after I'm done with this pod, please delete it. I need a name of the container, and I will specify an image called Alpine, and I will tell him the same thing, like I need to go to the shell access. I think it's called -rm. Okay, it's what exactly it's called. Just a second, let's have a look what it's called. Yeah, the problem is that you're not executing anything. You actually wants to run it. It's pulling the Alpine image. That might take some time. Yeah. So this is an Alpine, which would, yeah, it's an Alpine. Okay, let's add a curl. Because I need curl. Let's now, let's do? Let's call this thing. I'm not sure whether this is, yeah. See, we get the hello world. Because this is an internal cluster IP and this is the container port that we mapped 8000, and the Kubernetes is smart enough that it has already done the port forwarding from 8000 to 8000. Okay, so that's the Kubernetes smart enough that is already the port forwarding. That's why you're able to access the 8000 from outside that container. Otherwise, this will do the same thing which Docker gives us. We have to do a manual port forwarding, but Kubernetes was smart enough to do it for us. So we were able to access this, right? And now this pod is deleted. So now if I do a pods, I will not see this is getting deleted right now because I've exited from it. It will eventually get deleted. Let the middle one go. Yeah. Now you look at this, like this pod will have an IP. I make so many typos while typing. Yeah. This has like 10.244.4.36, and I think our one was 10.2. So we were hitting on 436. Okay. But this one might have some different IP. It should have, otherwise. It's really weird if this both in the same IP. It's at 045, right? Now think about this. You want to access this service, right? This pod, which is running your code, and I have two of them running. I might be 3, I might be 4, I might be 100 running. I cannot store all the IPs, right? This is not feasible for me, right? Let's say I am writing a front-end code or a server-side rendering I'm doing, or maybe this is my order service and I have an inventory service. An inventory service wants to check something with the order service. So I'm writing a code and I'm like writing a code in Flask and I want to access this code in the Kubernetes cluster. How do I access it? Because I don't know which IPs these are running on. And maybe these things needs to be rescheduled. Maybe one of the node goes down and these things are rescheduled into a different node and we will have a completely separate different IPs. So I need single point of, first of all, I need two things. First, I need a single point of communication to all my pods for that kind of, you can say, container image, right? If it's a Flask service, I need a single entry point for Flask service. Or let's say if it's a container, you can say, let's just say order service. I need a single entry point for order service. I need a single entry point for inventory service. Okay. And then internally, how you load balance, that's up to you. How many pods are running, I don't care, right? That's the problem of order team. I only care about my inventory team, right? Let's say that's generally how you do. Different teams deploy different things. And you just need to, they just give you that, okay, our order service is available at order service at 5000 port. Just access it from there, and internally we will manage how the order service is running. Okay, that's what I need, and that's what everybody, that's how the communication should be. Now that's where the services come in Kubernetes. Okay, so let's look at those things. Okay, services. Services is an abstraction layer on your pods, right? So the way deployment do is it has an you have a type pod, we call it a selector, and same goes the service. You give it the same selector for the pods, and then all those pods have an abstraction layer on it called the service. Okay, it's like nothing is running. It's an abstraction layer on it, and when you forward a request to a service, the service forwarded to a just do a forwarding to your port, right? It's like, kind of like a reverse proxy server. Okay. Now the question arises that how the service find the pod, right? Pod has like what, so many IPs, right? And they might be keep on scheduling and rescheduling in different nodes depending upon the space requirement, or they might be just scaling and up and scaling down depending upon your load, right? How does service keeps just all this thing maintained, right? Server doesn't maintain any of these, right? It's just an abstraction layer. It's just a way, it's just an entry point to it, right? The thing which does all this and which is very important component which might answer a lot of your question is called the kubeproxy. So kubeproxy is a really important component of Kubernetes. Okay, so kubeproxy is running on each and every node. Okay, and it is running on each and every node, and it has a thing called IP tables, right? So it's maintaining the information of which pod is running on which nodes. Okay, first of all, it maintains the information of its own pods because it's running on one of the node, and then it gets this information from the kubelet. Kubelet gives this information to kubeproxy. Kubeproxy stores in an IP table. Okay, these pods are running on my node, and then it sends this information to Kube API server, which is fetched by all the kubeproxy running on different nodes, and then they update their own IP tables with the information. Now, every kubeproxy running on every node has the information of how many pods are running at which IP and which different nodes. Okay, and all the nodes are connected to each other internally because it's a cluster. It's like a part of a same VPC, virtual private cloud. Now, when a service comes live, let's say order service comes live, and order service says that I'm the single entry point for all the pods which are of a type of order. Okay, that information is given to the kubeproxy. Now kubeproxy updates its routing table, the IP table, and says any request which comes to this particular IP, which is the IP of the service, I need to forward it to one of these node pods, and those pods could be running in different nodes as well. Okay, this is the same thing. So it comes to service A, the request goes to the queue because the IP request goes forward to the kubeproxy, service forwards to kubeproxy that this IP request IA and is forward to kubeproxy. Now kubeproxy will transfer it to maybe to a different node for a different pod. Maybe it's not even running that pod in my node, right? It's possible that might not be running any pod of order service, but the request comes to kubeproxy of my node, so I will forward it to the whatever pod which is a part of, which is basically order service. Okay, that's why it has the information of all the nodes and all the pods, right? And each kubeproxy service has it, and it runs on every node by default. Okay, and this is a service which also do the load balancing for you, because this is a service which is actually forwarding the request to the correct pod, right? Because if you're going to call a pod directly, then you're bypassing all of these things. Then there is no load balancing and nothing else thing. But if you generally we use it with a single entry point, right? Because we don't know the IPs of the pods. So that's why we call it a service. Service gives to kubeproxy. Kubeproxy knows, okay, you are coming from this IP for this service. Okay, you might need to go to this type of a pod selector, and then it just find the IP of the pod and it just forwards the request to it, and it just keeps on doing it in round robin fashion. Okay, so that's where the kubeproxy comes in. It's a very important component of Kubernetes ecosystem, right? And yeah, so we can just read it. It just manages the connectivity between pods and services. Kubeproxy watches the API server and continuously map the cluster IP to the healthy pods. Cluster IP is the IP of your service to the healthy pods by adding and removing the destination rules in the node's IP table subsystem. That's what it does. Okay. Another thing is called the kubedns. So service as an IP, we call it the cluster IP, right? But the same thing, yeah, IPs change. I don't want to work on IPs, right? IPs are not stable. I need a name. I need like a DNS system. That's Kubernetes always comes with a kubedns system. And it just whenever a service comes live, it registers itself with the kubedns. Okay, this is my name. This is my IP. Register me. Now you call the service with a DNS name. Let's say order minus service. And then the request will, of course, Kubernetes internally will forward the request to kubedns, get the IP to the corresponding service, and then forward the request to the kubeproxy. That will Kubernetes manage it for you. But generally, we always access it on the names. We never do it on IPs, because IPs are not a very good way of accessing information. Okay, there are three types of services that you can expose. There's a cluster IP, which means it's internally to the cluster. The IP, basically like a private IP. Node port is basically a service which is exposed through a port on a node, right? And it could be, generally that node is exposed on all the ports, so the same port. And then of course the load balancer service, which basically exposes which basically starts a load balancer service of actually a cloud service provider. And then whatever that external IP is, it is internally mapped to one of the service. We'll see all those three things now because it's important. Yeah, so let's see the services now. Okay, this might make it more clear. Oops, kubectl. We have any service running? We are just Kubernetes running, right? This is a cluster IP. If you look at it, this is the internal IP of the service. Okay. Um, 1 second. Yeah, let's start with the one service.yaml. Okay, so same thing. We are using an API version 1. We are type service. The name of the service called the Flask service. Now the selector, same thing. I want to select Flask app. Whatever pod is running with a selector name of Flask app, those will be under me. Type, let's not use a load balancer. Let's start with the first one. Let's start with a service called cluster IP. Okay. Now this is the target port. This is where the request will be forwarded to 8000, because that's where your pod is listening to, on 8000. And this is my port. This is the port of the service, right? You can use 8000 same, or you can use it like I'm using 5000 for my service port, and I'm just using a protocol called HTTP. Okay. Now let's apply. All right. Get service. Okay, so I have a Flask service running now, which is running on this IP at this port. And I don't have any external IP now. But what I will do now is scribe. Okay, this is where, yeah, look at this. This is a target point of 8000, and it has mapped the two pods already, right? This information has been mapped by your kubeproxy. Kubeproxy has mapped it, and this service is just showing it to you in a very easy manner, because you cannot access kubeproxy directly. So it's saying that what has done is it has find all the pods which are running with Flask app selector, and it has just mapped those pods as an endpoint. So whenever you access this IP at this port, it will be forward to one of these. Okay. Now these could be running in different nodes, doesn't matter, right? That's the kubeproxy's responsibility to get it. So let us access now this IP. Right. I think I have minus rm. Yeah. I think it should. Yeah. It should. But this IP is internal to this cluster, so see, I'm able to access it. I don't know which pod it's making the request to, but I just don't care, right? I also does not care if I also don't want to work on IPs, right? There's a DNS system already in place for me, so I don't know. Oh no, it's not a Flask. What it's called? Oh, it's called a Flask service. See, I'm able to access it on Flask service as well at the port 5000, which I specified, and yeah, it works beautifully. But I would not be able to access it outside the my cluster. So this is very good for this is very good way of creating internal microservices. There are a few microservices which you don't want to expose to the outside world. Maybe, I don't know, GST calculation service, and we have few like whether inventory service. No, inventory you might want to expose. Maybe GST calculation service or any other third-party services or internal services that you don't want to expose to the outside world, and just create a cluster IP service, and it will not be exposed to the outside world. There's no way to access the service from outside the cluster because it doesn't have any external IP with it, right? Now let's make it accessible. Yeah, so there are two ways to make it outside. One is called the node port. Now, what node port be done? Just similar things. Actually, node and port, the same thing. If you read it, it will expose one of the port on one of the node for us. Let me just apply it again. Oops. All right. So now what it is done, we don't have an external library, that is fine. But what it has done is it has mapped the 5000 port to the 32240 port of the node. All right. And this port is exposed on all the nodes by default. Now this is open. This port is open for all the nodes of, and this is where it's basically forwarding the request to. So if I can get my node IP, okay, I might have a node running. I only have one. You can, even if you have like more, it doesn't matter. This is one is a, this is the old node. So this is the IP. The master pool is the IP of the node, right? And I should be able to access it. I'm in my local right now. Control shift. I'm not in the cluster or anything, but I should be able to access this same service. This is the IP of the node, and what is the port that we have mapped to 32240, right? I got a hello world back. Now you should be asking it, this IP is of one of the node, right? It could be like, I only have one right now, but let's say you have 15 nodes running, right? Doesn't matter which node's IP you picked, the request will anyhow goes to the queue proxy first. And because what will happen, it doesn't matter which node you hit in, it will come here first of all, and it will see that this port is mapped to this port 5000, which is basically this service, and then this IP will be forwarded to the queue proxy. Then it doesn't matter which nodes you are on, right? It's exactly the same thing. You call this node for service A, it was not present on service A, was nothing in here, so queue proxy just forwarded to a node which it would have been present. If would you have heard 10.1.1.63, then this thing would not happen. It will directly just go to pod A because it has that pod A service running. So that's where this thing comes in, right? But generally what we do is we can also do it in load balancer way. Let's just change, sorry, let's just create a type load balancer. This will take some time because what this needs to do is this needs to get a load balancer from DigitalOcean. Sorry, not deploy. Yeah. Okay. Cluster actually, this external IP is pending right now. So now what is happening is I just got something. Okay, what is happening is it's getting a load balancer for me. Okay, no, it's not getting a load balancer. Where is? Yeah, networking. Different things. Load balancers. Yeah, now it's trying to start a load balancer for me. It might take some time, I suppose. Yeah, it will take some time for it to start a load balancer. It's now connecting to it. It has a public IP and a private IP of the VPC. And if you, no, it wouldn't have, I won't print anything right now. We just try to start the load balancer. Once the load balancer is up, you will have an external IP which you could use. So you don't have to actually know what is the IPs of your pods, or sorry, nodes. You can just start a load balancer for your service, and then you can just directly access that service from that load balancer. Hopefully it will start. And this will get provision from whatever cloud service provider you're using. So if you are using, let's say, GKE will offer you one of the load balancer, and then AWS will offer you its own. Okay, yeah, it's not there yet. Yeah, let it change. Let's watch it. I think we are provisioned. No, we are not yet. Some time. It takes some time for it to start, and then So the status is still collecting, it's still trying to get information. Yeah, it's still trying to get information. No, it's still trying to get some information. Okay, I don't know, it take a lot of time to get into it connected. But once it's live, we will get just an external IP here. We can just maybe look at it after some time. And then we can just access that service on this IP. And of course, we'll see. And this IP will map to this port directly. So yeah, it would have been started and it would have been really good. But yeah, we have it. Okay, great. So we should have rules now. Yeah, it's healthy. Perfect. Let's look into it. Networking. Okay, we have some firewalls which have already been set up. Okay, and we have a public gateway IP, and we have our own IP, external IP, which we have been exposed with. So we should be able to access it. This will not work because we're not running on anything on port 80. I think we're running on 3240. This I'm not very much sure about. 32440. Yeah, I was correct. We were running on maybe 5,000, right? Yeah, because that's what your service port is. It will not, because the node port is not irrelevant to it. The service port is always relevant to it. Yes. So this is how you access it. So now this is, you have given an external IP. You always access to this IP. It doesn't matter which. Now you can have like 20, 30 nodes running. You don't care about what the IP of that node. The node could get deleted, it can get started, but this IP will always remain constant because that's basically the IP which is provided to you by the your load balancer. So yeah, this is what the services do, and I think I've taken a lot of your time. It's almost 6. So yeah, guys, I think that's it currently from my side. We might have another session on more deeper understanding of it. But yeah, I'm open to questions. When a cluster scales up, then how does load balancer know that the new node in VM is added? So yeah, so this is done by the same kube proxy thing. So whenever a new node comes in, kube control manager knows it. It forwards a request to the kube proxy and says, hey, this node is coming up, and these are the pods which are scheduled on it. Whenever a pod gets scheduled, the kubelet gives information to the kube proxy, and all the kube proxies IP tables are synced in between with each other. That's how we know that bit nodes are running and how it can route the traffic to it. Hope that solves the question, Keshav.
Yeah, we can go
How
ahead with the
does we
next
put a limit
question.
on the size of the memory taken by the container? I just showed you that. You can just do it with deploy. This is how you put a size restrictions. Request is the minimum that you need to run, and the limit is it should not exceed this. So it will not schedule any place where it is have less than 100 MBs of RAM, but it will not let it exceed 150. Yeah.
Okay. I hope it answered your question. So yeah, we'll move it to
Yeah.
another question.
Did you okay? How to put Docker containers and Kubernetes node, the same deploy.ml file that you just saw. We're just giving it an image name, and we're just giving it the Kubernetes to run that. It's really simple. Can you show load balancing with Kubernetes? Yeah, so it's done by kubeproxy internally. To show you the load balancing, we would need really actually some throttling of the. We would need some throttling. We would made some decent request, and then we need to log it inside a pod. But it's done by Kubernetes by default, because if I show you, one second, yeah. If you look at this service here, this is already, we've got a lot of information now with the load for the load balancer thing, but yeah, this is already going to be load balancing on these two on round robin fashion by default. So this is done by kubeproxy internally. It gets really difficult to actually show you it right now, but yeah.
Okay. I like we
Yeah,
can move
I
it to
think we
answer
can move
some.
it. Yes.
So we can just go ahead with
Is
another.
it possible
Okay,
to
both of.
schedule start a pod? Okay. I think there's one. It's just showing me one here. It's
Okay,
weird.
I
Okay.
moved it to
Is it
answer.
possible to schedule start?
Yeah.
Okay. This I have. Yeah, you want to schedule start a pod or you want to schedule start a job? So you can always schedule start a pod with like a. If it's a single pod, then yes, you can do it. You can create a type job. You can specify the time you want it to run, and then it will create one of your pod at that time. It will run it. And if it's a long running pod, then yes, it will be keep on running, or it just have something which needs to do and then get killed. It will get killed and then it will start again at the same time, just like a normal cron jobs run. That is doable for a pod. For a real lifetime system, there's no need to schedule it, in the sense, because you already have an autoscaler for you. So if you're thinking about I think the reason why you are coming from is something like a tsunami load, that you know that you're going to get a tsunami load, for example, which Hotstar gets whenever IPL comes. They know that the load is going to come, right, eventually. And they know that when the IPL will start, the load will come. So what Hotstar used to do is Hotstar always pre-schedule before. It always get a multiple instances running at the same time. But with Kubernetes, the thing is, either you can change your deploy.yaml to support that, or you can just leave it to the autoscaler. It's very good. You can just leave it to the autoscaler. It will, because eventually the load will just, the moment it start increases, it will keep on scaling it. But as such, I've never seen somebody do a preemptive allocation of resources in Kubernetes. It might be possible, but frankly speaking, I've never done it. But I think you're coming from the Hotstar kind of thing. Yeah, they do, but they don't do it in Kubernetes, I suppose. They just preemptively schedule the number of nodes they need. So you can just add more nodes to Kubernetes preemptively, maybe through any command or something on your cloud service provider. But I've never done it through the configuration part of it. So yeah, I might have to check that.
Okay. So does it answer both the questions? Should I
No,
move both?
is it possible to start schedule? Is it possible to connect between pods? Yes, you can connect between pods. The thing which I just started was a pod. So I think you might miss this, but uh, so let's take one. So let's take this pod IP. kubectl describe pod. What is the IP of the pod? 10.244.035, right? Let's print this. And what I'll do is I get in the upper one. So let's go into the, okay. So what happens is now I'm inside the top pod, and this is the IP of the pod which was below. So I can do this. I can just apk add curl, right? And I can just do a curl on this. This is how you communicate between pods, but never do it, I would say, with the IP. Just run, just access the service which this is connected to. I think which is the Flask service. You will get the same result. All right, because the services are works on DNS and everything. So you can just, yeah, you can always communicate between pods. That's the whole point of Kubernetes. If it's not communicating between the pods, then microservices will never work. Can we make the memory allocation dynamic instead of giving fixed size memory? I'm not getting the point. Dynamic. So pods are the smallest unit of replication for Kubernetes. You tell him that this pod will not exceed 100 MB, and then when the load increases, it keeps on starting more and more pods. Okay, that's the whole point of it. You what you're trying to, I think, you're talking about the vertical scalability. I think you want to just keep on adding more RAM and resources to one single pod. Then you're going towards a more of traditional big fat VM approach, right? Oh, I'm getting more requests, let me just add 2 GB RAM more to it. No, scale horizontally, right? Just keep on creating more systems, right? Create 50 pods, 1,000 pods, but just don't add things into one pod. That is not why Kubernetes is designed for. It's designed to replicate pods. All right. No vertical
Move.
scaling. Yes. I think that solves the question for that.
Vivek, like if you did not get the answer, you can just raise
Yeah,
hand
you
so
can
that we
always
can
raise
answer.
hands. Yeah, and we'll
Yeah.
discuss it again. Uh,
Yeah.
but
Right now, moving to answer.
yes, she's asking, but IP gets changed, right? Okay, I'm not.
Santosh has asked, like in the previous question when you were answering, right? So in that itself, he has asked.
But the IP gets IP for what? Pods you're
I
talking.
think it was regarding the pods
Yeah,
and
yeah,
all.
IP do get changed. Yes, IP might get changed, but you don't care about the IP, right? You care about the service that is overrunning on the pods. That's what I say. You care about the name of the service and the port that it's running. It will never change. IPs always get changed. Never work on the IPs. Always, always talk with Flash service running at 5,000 port. Now, this service will shoot it to whatever IP the pod is live on, and that information is stored inside kubeproxy's IP table, and that information is being continuously fetched by the kubelet as well. If one of your pod goes down, the IP tables will remove that entry, and the another pod comes in, it will get their entry into the IP table, right? And never works with IP. IPs are bad thing. They do get changed. Yes, that is correct. All right. Yeah. Uh,
So, okay, guys, do you have any more questions? I know it was a long
yeah.
session, but yeah, this particular topic we needed that. Otherwise, as we have covered only the basic thing, right, and still it took that much time, and we are planning to go ahead with, I would say, extended version. I would say the intermediate
Yeah.
level, and we'll work on that and we'll come up. Your feedback will be really appreciated if you have any feedback on that, like on that particular thing, on the Kubernetes, like if you have anything, that would be really appreciated. And I have shared all the links in the chat section. So all the links, like when you can follow Recro, you can connect with Ankur, you can connect with me, and you can subscribe to our YouTube channel. We will be uploading the YouTube videos. Like there was a delay in the YouTube videos, and that would be there. I would say by tomorrow, and within the next week, all the videos will be uploaded there. And please join our backend community. So after the section, I will be sharing the link of the presentation and the code in that community. Apart from that, you will be getting a mail from me once you'll be receiving a recorded session. Otherwise, if you need a easy access and early access, you can always join the community. Also, like to whoever like who have not filled the feedback form, please do so. It would be really helpful for us. And thank you so much for taking time out of your busy Sunday and joining this session. And thank you so much,
Thank
Ankur. You
you.
have put in a lot of effort to do this session, I know. And it was really informative. And I feel that people who have attended the session, they also feel the same thing, and it's a learning way for them, and they have learned something new here. So thank you so much, Ankur.
Thank you.
And on behalf of all Tech Crew, I'm gonna say that, and on behalf of like all the community member here.
Yeah. Thank you. Thank you for having me. Yeah.
Okay. That's great. I think we'll just take a
Yeah.
leave. Guys, if you have any more question, you can be in the social launch, and then Ankur can join in the table. Otherwise, you can anyway ping in the community chat section, and we'll reply there.
Sure. Sure.
Okay. Thank you so
Thank
much,
you.
guys. Bye bye. Good night.